Hello everyone and welcome back to the video lab term work series. Uh, in this video we will cover the term work number 7. So let's discuss the problem statement about it. The problem statement is straightforward about bubble sort. So it is saying sort the given set of numbers using the bubble sort. So we need to take some set of numbers, a list of numbers. They will be in the random order. Sort we need to print the sorted order of that number using the bubble sort technique. So let's begin. Yes. So bubble sort algorithm is one of the famous algorithms for implementing the sorting uh, technique. You will also find other sorting techniques such as merge sort, quick sort, insertion sort, but bubble sort is basic and easy to implement algorithm. So how bubble sort works is it works by comparing the first two elements of an array. First of all, the elements will be stored in the single dimension array, the integer array, uh, and it starts comparing the first two elements. If the first two elements are not in order, in order means the first element should be less than the second element. If they are in order, we will not do anything. We will consider second and third element, means we will be moving one step ahead. If in case they are not in the order, we will be swapping the number, and this process goes till the last element of the array. We will better understood it by the diagram in the next slide. So I'm just giving a small brief idea about bubble sort. And if there are n elements to be sorted in the array, say there are n elements, then we need to repeat this process. That is comparing elements and swapping if necessary. That this procedure we need to do n minus one time. So if there are 10 elements in an array, we need to do this operation 9 times in order to achieve the correct result. This diagram will give you the exact clear idea about how the bubble sort works. Let's say the given array is 7643. Uh, as you can see, there are 4 elements. We need to do this operation 4 minus 1, that is 3 times. That's why you have here three set of passes. First pass, second pass, third pass. The passes are nothing but doing the process again and again. That's it. And yes, 7643. First we compare two elements, 7 and 6. Whether they are in order? No. Like 7 is greater than 6. So swap them. It becomes 6 and 7. Later compare 7 and 4. Whether they are in the order? No. Again compare and see whether the next 7 and 3 are in order. So you will see that 7 is less than 3. So 7 will come to the last position in this, like here. And the point to be observed over here is after one pass, we will be having the maximum element of the array stored in the last position, means last entry of like the last index, last place of the array. Here in this array, 7 is the greatest element, the maximum element, and it will be getting its correct position. Actually, it should be in the last only whenever we have a sorted order. Sorted order means we are here referring ascending order, not descending. We are here referring the ascending order for the array. So uh, 7 should be the last element whenever we tell the ascending order. So 7 has got its correct position. Let's go to second pass. 6437. Whatever we left with this array in the first pass, we will take it in the second pass. Compare 6 4. They are not in order, swap. Compare 6 3. Not in order, swap. The one more thing, again, a similar thing you need to observe over here is you need not to compare the 6 and 7 because already 7 in its position. You can save the time of comparison of 6 and 7 because anyway 7 is in the last position. You need not to check it whether it is greater than 6 or not. It will be definitely greater than 6 only. You can take other examples also and see. At the end of second pass, you will be getting the second maximum element of the array positioned at its correct index. Like 6 is the second maximum element and it has been placed at its correct position. The remaining array, that is 4, 3, 6, 7, take it for a third pass. 4, 3, 6, 7, compare. They are not in order. Swap 3, 4, 6, 7. Here you need not to compare 4 and 6 because you know 6 is already been placed. So you can do it until 3 and 4 means only one swapping and remain means leave it. You need not to compare it for uh, whether it is 4 6 or 6 7. So you can see that we are saving a single swap a single swap operation each time in uh, each passes. Like here we got the 7 placed correctly. Here we got the 6 placed correctly, and in the second pass we did not compare the 6 and 7, and in the third pass we did not compare 4 6 7 because they are getting automatically placed at the correct position. So that's why this point should be kept in mind that you there is nothing wrong if you compare whether 6 is greater than 7, but it is just waste of time and computer resources. So you need to make your um, um, uh, a program more efficient and more a less complexity program. You will be going through the complexity concepts in the your upcoming semesters, but for now assume that you should not write your program which consumes more memory and more time. A simple algorithm for implementing the same. Let's go through it. Read n. N is the number of elements which we are going to store in the array, and read those n elements into array A. Say name of the array is A. Here we need to have two for loops. Why two for loops? One for loop is to check the number of passes, three passes. So we need to keep track of all these three passes. So one for loop needed for that. Another for loop is for iterating over the array. Once we have in each pass, we need to iterate from 7 to 3. You can see here, we started with 7 and went till comparing 3. So comparison from 7 to 3 requires another for loop. So two for loops are needed. For I equal to 0 to n means we are starting from 0 and yeah, going till n minus 1 means we are doing n minus 1 time the passes. You can see n is 4 means number of elements 4. We have done 3 passes. So if the elements are n, we have to do n minus 1 passes. Inner for loop j equal to 0 to n minus I minus 1. Why this n minus I minus 1? Why not n minus 1? Is because, as I told, you need not to compare the 7 when it gets placed at the first pass. You need not to compare the 6 when it gets placed at the second pass. So means we are placing one by one element maximum elements at the correct position. So just reduce the number of operations by I each time. Like in the if the I is like 0, in the first pass you need to do n minus 1 comparison. Yes. In the second pass you can do n minus 2 means a number reduced to like if we have 10 elements, in the first pass you will do 9 comparison, in the second pass you will do 8 comparison, because you know the last element is getting placed at its maximum correct position, so you need not to compare it. So and that's it. And yes, in i- these two for loops are called as nested for loops. And here we have a condition, if condition. If condition is for like you can see a of j is greater than a of j plus 1, then the procedure is for swapping. Means, as I told, if they are not in order, like 7 is greater than 6, a of j is greater than a of j plus 1, then we need to swap them, like temp equal to a of j equal to a of j plus 1, a of j plus 1 equal to temp. We are taking a variable temp and we are putting the value of a of j in that, and we are assigning the value of a of j plus 1, that is next element to the previous element, and whatever value we have holded in the temp, that is the original value of a of j, we are adding it back at the a of j plus 1. Simple swapping concept. I hope you have solved the swapping problems in your uh, classes. And then we are ending the both the loops, and after that we are displaying the sorted array. So this is just a sample input output for this program. That is, let's say I have n equal to 4. Enter the, if the user enters 4 and enters the 4 numbers, I should display them the sorted order, ascending order of the element. The technique to be used is bubble sort. Let's solve the code. The code is pretty simple, as we have already implemented the algorithms. Solving the code will not be a big issue, because once you can get the code, means once you can get the algorithm, you can definitely get the code. Let's start by including the header file. And let's have directly a main function. In the main function, we need to have uh, int n, because we need to read the number of um, elements which we are going to store. Let's print a message to user saying enter n. Use the scanf to read it from user. Printf array elements. Once for reading the array elements, that is n elements, we need to have a loop starting from I equal to 0. Why I equal to 0? Because the array index starts from 0. So int I equal to 0. I less than n means I need to go till n minus 1th index. So therefore I am setting up I less than n, and read them using scanf. Before that, I need to declare an array to store the values. Let's say int a of n means a array containing n elements. Scanf percentage d, we are reading an integer value and storing it array's ith index. Once we have this, that is a reading of input, let's start the bubble sort. Bubble sort start. Let's have for int I equal to 0. As I told, the first loop is for keeping track of number of passes. I equal to 0 to I less than n means n minus 1 means we are doing n minus 1 passes starting from I equal to 0, or you can have I equal to 1 to I less than n. Both means the same. Another nested for loop needed for keeping track of the iteration over the array. J equal to 0, j less than n minus I minus 1, because why we are incrementing it by why we are using n minus I minus 1 is because at each pass we are placing the maximum element at its correct position, so we need not to compare the last element for the second pass and second last element for the third pass and so on, as I demonstrated it in the slide. We need to compare whether they are in the order or not. That is, a of j, say first element, whether it is greater than a of j plus 1, means it's next element. Consecutive elements we are comparing. If the previous element is greater than the next element, then we need to swap them, have a variable called temp. We are doing the same as in the algorithm, just we are writing it in the form of C language valid statements. A of j and a of j equal to a of j plus 1, then have a of j plus 1 equal to temp. Simple logic. We are using a temp variable which can hold the value of a of j. Once it holds the value of a of j, we are putting the a of j plus 1 value in the a of j. We are putting the value of a of j plus 1 in the a of j, and we are fetching that temp variable, which is the original value of a of j, and putting back at the a of j plus 1. Just we are reversing the swapping the values of two variables. And that's it for bubble sort. After this, say here bubble sort ends. Here I can say bubble sort ends. Once the bubble sort ends, I need to have printf the sorted order. This is nothing but just some simple message for int I equal to 0, I less than n I plus plus. Means we are just iterating over the loop, and we are printing the each element. Printf percentage %t, and we are printing a of I. We are just iterating over the array and printing each element in the array and saying that they are in the sorted order. Let's have a space here so that they can be in the well displayable form. Enter n, let's say 5. Enter array elements 67, 43, 20, 49, 55. The sorted order is 20, 43, 49, 55, 67. Yes, and because they have been printed in the correct order, we can say that the bubble sort is working correctly and we have implemented it successfully. Thank you.